Hello, friends from everywhere. I would like to introduce our research recently. My lab is called Bio-based Polymers. You can call me Yijun. I'm Yijun Chen. I come from Chung Hsing University. So my department is focused on forestry science. I'm associate professor. It's my pleasure to show you our research. So where is Dongxing University? So actually it's in median of Taiwan. So as you can see, we are in Taichung City. This is our building. Is you can see there is forest. So if you have time, please come to Zhongxing, and we have a really good history we can share with you. So we start in 1990. So we are over than 100 years. In Department of Forestry, we have 4 teams. For forest science, we have forest management, forest biology, and conservation. We have the other team is about wood science. So we have 2 teams, wood chemistry and wood physicals. I belong to wood chemistry. Moreover, I would like to introduce experimental forest for you. We have a full area is in north of Taiwan and in middle of Taiwan and in south of Taiwan. As you can see, this one is the biggest one. It's Huisun Forest Station. Moreover, it's very beautiful. In Huisun Forest Station, we have a beautiful view, hot spring, and a nice coffee. If you have time, please come to Huisun Experimental Forest and enjoy the nature landscape. And I would like to introduce myself. I graduate from Forest and Department of Chemistry Engineer. So I would like to combine 2 knowledge. Moreover, we think we can figure out some problem. So I also have some experiments in biomedical science. So maybe I can work with drug delivery system or 3D cell culture. I have experiments about that. Nowadays, maybe we can consider some resources is fewer and fewer. In forest, we have a lot of resources. We can use them all or nothing is, and moreover, nothing is waste. Wood materials can produce pulp, paper, and energy. Moreover, maybe we can use for chemicals and construction. So the main wood composition are cellulose, hemicellulose, and lignin. So the percentage of them is 40 to 47. Moreover, the hemicellulose is about 25. Then, as you can see, is lignin. As you can see, is aromatic structure. So the percentage of lignin is about 16 to 31. My major is use bio-based materials to synthesize eco-friendly polymers. For example, hydrogel and polyurethane, phenolic resin, and nail particle. So it can be controllable systems, foam, or composite and thin and coatings. So it depends on the product. We can synthesize it. Woody materials is sodium. I think everybody already know. How can we use the natural resources smart? So we can use liquefaction technology to transform wood as liquid, and we can use it like chemicals. We also use plant oil. Maybe we can modify it to let us to synthesize more product. Moreover, we can synthesize phenol formaldehyde resin and polyurethane resin. Moreover, we can manufacture some green products. I learned the liquefied technology and polymer knowledge from Professor Li Wenzhao. Then we can use liquefied products to synthesize phenolic formaldehyde resin. As you can see, original, the wood or woody materials is like sodium. So we can transform it like a liquid, as you can see. Moreover, we can add some formaldehyde and control our ratio, and we can get some resin. So as you can see, the beginning the structure is aromatic, so the structure is similar with phenol. So we can add some formaldehyde and get the resin. First, we use muscle bamboo. It's very common in Taiwan. Muscle bamboo can be liquefied. FTIR result shows decomposite chemical component after liquefaction. The main component has been degraded, so we can use it to synthesize resin type alcohol soluble phenol formaldehyde resin. Moreover, we check the property, we can use it. I think everybody knows bamboo is very common in Asia. Moreover, it grows very quickly, so we also synthesize the resin type water-soluble PF resin from liquefied bamboo. Maybe in near future, we can use liquefied bamboo as a kind of chemical. We also synthesize the resin type water-soluble PF resin from liquefied wood. I think everybody already know our main product from forest is wood. So when we cut the woods, and then we will prepare some timber. Then maybe we have very many wood residue, and we can get the residue for some liquefied wood. Then it's a kind of a very good chemicals. In traditional way to synthesize normal like PF resin, it needs some equipment. Moreover, it wastes a lot of energy to heat it. So we think about how can we deal with it. When we mix liquefied wood and formaldehyde, it's exothermic reaction. So it's already reacted. Moreover, we think about what is the sodium. So we grind it and we can get some crude powder. Then we heat it. It's melting. When it's melting, we mix some cold linkage, for example, hexamine. Then it's become sodium. It's become resin. We're successful to prepare it. Moreover, the powder we can use for some moldings. In traditional way, actually the property is not really good. Then we change to use the powder. The normal like powder is make the moldings with low water absorption and good diameter solubility. The bio-based molding also shows pretty good thermal solubility. I think it's better than wood and some traditional. It's similar with traditional PF resins. We also think about what kind of application we can use. The epoxy resin is high-cost product, so we try to mix it with liquefied wood. Result shows liquefied wood can replace epoxy resin, which has really good curing property and bonding stress. On the other hand, we would like to use bio-based materials for other polymer, for example, polyurethane. Polyurethane are made from diol or triol and diisocyanate or triisocyanate monomer. The isocyanate components contain the functional group is NCO. The NCO can react with amine, water, alcohol, or COH or urea. After the reaction, the least formulation of the urethane leakage. Moreover, as you can see this figure, the US polyurethane market size keep growth. So as you can see, in near future we will need polyurethane more. We use polyethylene glycol and glycol as co-solvent to liquefy the wood-based materials. So for example, rice husk. So why we use rice husk? The rice husk contains some silica. Moreover, we want to prepare polyurethane foam. So we add some bromine H, surfactant, catalyst, and isocyanate and mix it, and we can get polyurethane foam and cut it. We can get the product. We use TGA curve to check the thermal property. As you can see, increase the NCO ratio and use liquefied rice husk can increase the thermal property. So maybe next time we can use some silica materials or just use liquefied rice husk. Then we can increase the thermal property. Organic solvent is dangerous and toxic. We can use liquefied lignin to synthesize waterborne polyurethane. So the solvent is water is really safe. Moreover, we compare two kinds of exchanger. The first one is 1,4-butadiol, and the other one is diethylene amine. So two kinds of exchanger and two kinds of polyol. One is PTMG, and second is liquefied lignin. We think we can synthesize a new type of waterborne polyurethane and contain some lignin. The result shows the lignin and exchanger can change the property. Moreover, we also use liquefied cellulose to synthesize waterborne polyurethane. The result shows liquefied cellulose. The structure is different with PTMG, so it can control the property of waterborne polyurethane. Especially, we can increase the hot segment ratio. Plant oil are one of the most important chemicals for chemical industry due to renewable and low price. Neem is typical grows in tropical and semi-tropical region. Neem oil has been used to replace fossil-based materials for industry feedstock. The main component of neem oil are main fatty acids. So as you can see, this is the main components. The other direction can be extracted from the neem tree. The chemical is great potential as a biocide for antibacterial and passive management. So we think about maybe we can synthesize it, but actually it's a many step and the price still high. So maybe we cannot easy to use it directly, but it's already contained in neem oil. So maybe we can use it for some antibacterial property. Also can prepare from castor oil. Castor oil contained in the seed. As you can see, this tree actually is also can produce from Taiwan. Castor oil is renewable resources and can be used as raw materials in industry. So actually, the structure is also like a polyol, so we can use it directly. Moreover, some research also indicates they can use the other multiplication way to prepare a new polyol. So polyurethane foam can prepare from cast oil directly because it already contains some hydroxy groups, so can react it with isocyanate and form the urethane bond. So my students do some research about it. So they prepare the polyurethane foam from three kinds of isocyanate and compare the property. Neem oil and its glyceride can modify the properties of cast oil-based polyurethane foam. So we can use esterification to get glyceride. Then also we mix different ratio to these chemicals. Then we get the pure foam and check the property. The results indicate when we mix neem oil and the glyceride, then we can improve the polyurethane foam property. Then we can optimize it. We also use rosin to improve property of a castor oil-based polyurethane foam. I think the structure you also can image is really hydrophobic. Moreover, maybe it can increase the thermal or mechanical properties. These results demonstrate the bio-based polyurethane foam are improved by adding only 2 to 4 % rosin. We can produce the foam with excellent mechanical and chemistry property, and we can control the water absorption and thermal solubility. Lignin also can use as functional filler for prepared polyurethane foam. Moreover, as lignin can increase the bio content, we can get homogeneous foam with flexible property. We can use it for some crushing products. The cast oil-based polyurethane foam can use as adhesive. So for the adhesive, we can manufacture some composites. So we also use 3 kinds of isocyanate to prepare it and compare it. We also use bamboo charcoal to prepare composite. The composite have excellent diameter solubility. The result shows the bio-based polyurethane composite have a high potential to use as eco-friendly building materials. Neem oil also can be used as renewable chemicals. In primary study, synthesized alkyl were reacted with TDI to prepare polyurethane coating with cyclohexanol and THF. 2 kinds of solvent is really dangerous and toxic, so maybe we can change it. We can use suffocate to suspend the neem oil in water, then the microemulsion mixed with water polyurethane to prepare the thing, and we can check the property. We also use neem oil glyceride to synthesize waterborne polyurethane. Then we also check the properties. As you can see, we can synthesize waterborne polyurethane come from neem oil glyceride. So it's different ratio. As you can see, when we add more neem oil glyceride, the color become yellow. So we can just use non-toxic solvent and only 2 steps, and then we can change the properties. And moreover, we can modify then a green process. Home message: maybe in near future we can have green chemicals, and with our teamwork, we can have really successful products. Thank you very much for your kindly attention.